All right, you're hanging with Hussick, and we're going to take up a couple of quantitative chem IB questions by request. Okay, this is a bit of an interesting question here. It says, when 50 cubic centimeters of a hydrocarbon, CXHY, we don't know what it is, that's going to be the whole purpose, can we figure it out? When it's burned in excess oxygen, 20 cubic centimeters of CO2 and 250 cubic centimeters of steam were produced. All these volumes are measured under the same conditions. What's the molecular formula of the hydrocarbon? Well, I would encourage you to write out the chemical equation for this. You're not going to be able to balance it because you don't really even know what the reagent is, but write it out, because remember, the point of, or one of the major points of writing a chemical equation, besides like being able to determine the coefficients and do the quantitative math about it, is to visualize it in a model. Okay, this is a model to help you visualize what's happening during this chemical reaction, all right? And let's just write in there what's given. So just organizing ourselves, I think, a little bit is key at the start. So there's 50 cubic centimeters of that, 50 milliliters of that. There's 200 milliliters of this, and there's 250 milliliters of that. Oops, I almost wrote I was gonna see if I could do it. See if I could like say milliliter, but write cubic centimeter. There we go. Okay, what's the significance of this? Well, these are all gases, basically, okay? We're gonna imagine that these are all gases, because that's kind of important to the context. This is basically a gas question. And what this question is exploiting is something called Avogadro's law. I think it's pretty much called Avogadro's law. It's this idea that when you have volumes, okay, the ratio of those volumes, presuming it's ideal gas, that's gonna maybe that's not even there we go. Those ratio of those volumes are gonna correspond with the ratio of the moles, okay? So in other words, like if you look at what this ratio is, and 50 is our base unit, that's one of those, and that, 200 divided by 50 is 4, so that's 4 parts of those and 5 parts of that. In other words, like the volume ratio is 1 to 4 to 5, okay, for volumes. And so also we know that the mole ratio is going to be 1 to 4 to 5. So in a way, we can go ahead and just write a 1 is the coefficient there, a 4 is the coefficient there, and a 5 is the coefficient there. How does that actually help us do anything? Well, if you look at like where all the carbon comes from in CO2, it is coming directly from there. There's nowhere else it's from. The oxygen's in excess, it's not adding any carbon, it's not really important here. And so basically we can assume that if this is, if it's going to produce 4 carbons, that there's probably 4 carbons there. Then look over at the water. Where's all the hydrogen come from? Well, it's got to come from that HY. How many hydrogen atoms are actually there? Well, there's 10 of them, okay? So it's either this compound, C4H10, or maybe it's like C2H5, because maybe we're balancing the equation in like a factor, a multiple, not in the lowest unit, not in the empirical unit, I don't know. So basically one of your answers, I would imagine, is going to have to be C4H10 or C2H5. So let's have a look, and lo and behold, the only option we have is C4H10. So that's got to be your answer there. All right, this next question also exploits Avogadro's law a wee bit, and we'll get to that in a second. Let's just lay out the landscape of this first of all. Which statements are correct about Avogadro's constant? So we want to make sure we know what we're being asked. It's the number of, it's the number of, it's the number of. What is the number of Avogadro's constant? It's 6.02 times 10 to the 23. What is that number? That is 1 mole, okay? So if we could rephrase this question, it's saying which of these statements is giving us 1 mole? All right, so let's start here with this guy, number 1. It says it's the number of ions in 12 grams of sodium hydride. So, geez, how many moles are in 12 grams of sodium hydride? Is that 1 mole? That's ultimately the question. How do we figure that out? Well, remember that moles are going to be the mass divided by the molar mass, all right? what's the molar mass of sodium hydride? It's 23 for sodium, and it's 1 for hydrogen for a 24. Remember, these are paper 1 style questions from previous exams, so you're not going to need a calculator to do them. You should be able to kind of do back of the envelope chicken scratch and figure these babies out. So around 24 grams per mole. Of course, we got those values from the periodic table provided. So therefore, the number of moles in here is, there's 12 grams, they said, right? Yep. Divided by 24. So there's actually a half mole. Okay, that's a half a mole. But it doesn't just ask us about how much of it. It says how many ions. Well, how many ions are there in a unit of NaH? There are 2 ions. There's an Na plus ion and an H minus hydride ion, which is kind of weird. So we're just gonna take that half a mole that was there, and we're gonna have to multiply it by 2 ions, because there's 2 ions in every unit, and that is 1 mole. Phew, that was kind of a roundabout way of saying, yeah, that checks the box. Okay, second one, let's look at this condition 2 here. It says it's the number of molecules in 22.4 liters of hydrogen at 0 and 1 atm. Well, there's this thing called, as I alluded to before, Avogadro's law. And part of Avogadro's law says that 1 mole of any ideal gas, and I guess we're going to assume it's ideal, 1 mole of any gas basically at STP, which is 0 Celsius and 1 atmosphere, okay, is going to occupy 22.4 liters. So in other words, this by definition is 1 mole. All right, on to number 3. Number 3, by the way, this value is in the data book. You wouldn't have to memorize that or anything. It gives you 22.4 for STP, which is 0 degrees Celsius and 1 atmosphere, and it gives you 24 liters per mole at SATP, standard atmospheric temperature and pressure, which is like a little bit warmer, 20 degrees or something. All right, anyways, moving on to 3. Here we go. It is the number of atoms in 12 grams of carbon-12. Well, that is by definition 1 mole, because remember, carbon-12 has a mass of 12, which means there's 12 grams in 1 mole of it. So if you have 12 grams, you have 1 mole, and thus the answer is D. All 3 of them are satisfying that condition.